Okay, so let's have some fun with that starter kit and those little sensors. Now, I bought this starter kit because it includes like 7 different sensors with it, so it was a more effective way to buy it all at once. But of course, you can buy the little sensors by themselves as well. Like for instance, this is the little mini per motion sensor that comes with it. So for $5.40 you can buy it by itself. So if you're watching this video and you don't have the starter kit, not a problem. You can actually buy these little modules, and there is also no need to have Grove connectors on your controllers. You can just make up a little cable and plug these things in directly into the pins on the actual modules, and you don't even have to use just Chow modules. You can use just any microcontroller at all. For instance, in the last starting episode, I showed you how you can use made up a little cable here with on this ordinary cheap, like $2.50 or whatever they cost, Chinese ESP32 Room 32 board. And some of these things like this M5 C3 stamp C3 has little holes in it, so you can actually solder. It actually comes with it. You can solder little growth sockets on there as well, so you can use that. And so the options are quite wide. Just because I'm using the starter kit doesn't mean that you have to as well. So I thought we'd have some fun here. Now, in my garage, I have a LED light which actually turns on automatically with movement, but it only turns on if it is dark. If the garage door is open, it won't turn on at all. And it is programmable how long you want it to stay on for. It would stay on for 5 minutes, 10 minutes, 15 minutes, whatever you think. So I thought we could emulate something like that with the sensors that we have. Initially, to get started, we will use this LED module to turn on an LED on there that would take the place of a bigger light, but we will actually hook it up to a bigger light at the end of it to show you some options with that. This here is a light sensor that came with the kit as well. Got a photo transistor on there, I think, and probably a little op amp or something like that to control it. And this thing actually comes back with analog values. I think it's 0 to 127 or 24, something like that. And then we have this PIR motion sensor. And what we have done is we've got you can see the image over here of the board, and of course the module is plugged in there. So we're using this port for the light sensor, which, as you can see, is actually marked D0. And I actually wrote down that particular pin there, which is the yellow wire, goes to the connector there that says SIG. That's the signal. So that is that. Then the LED module 2 is only a 3-wire one. These Grove connectors actually can be used for I2C, which means they've got 4 pins connected, but many of them have 3 pins connected because they are just simple digital or analog outputs, and the black and red wire, of course, is ground and VCC power that goes to the module. So given that we have on that one 2 we only have the one that says SIG again, and the one is no connected, so the white wire is not actually connected to anything. And because we got plugged into this one here, and as it says there is 2 connections there, 6 and 7, so we've got it connected to 7 because it's the yellow wire. And the other one here is connected to that port. Now these 2 ports are actually in parallel with each other because they are aimed at I2C, and I2C modules have addresses on them, so they can be connected to the same pins. And the controller will address, whichever module it wants to talk to. And that's the motion sensor. And this thing too, in fact, only has also it's only a 3-wire one, so it says here REL and no connection. And that means that again we're dealing with the yellow wire, so we are actually on the outside there, so that's going to be number 5. Now, one thing to keep in mind that this image here was created originally for the, that fit on the screen, for the this particular module here, which is the actual SAMD module, Atmel module. And as you can see, it has on every pin there D0, D1, D2, D3, D4, D5, D6, but all those pins also can be analog inputs or outputs, A0 to A6. And on the other side, same thing, we got D7 to D10 and A7 to A10. So in the sample code that Seed Studio presents you with, they will use pins like D0 and A0 and so on. But we actually have several other modules here, and if I put them like this, you might even be able to read what's on them. This, of course, is the one that I just showed you, the original Atmel Arduino module. This one here is actually an S3. This one is an RP2040, which is a Raspberry Pi controller. And the one plugged into the actual module here right now is the C3 module. So point is that if you are, depending on which modules you're using, these pins will actually have different IDs. Now the S3 is fairly similar. It has A0 and D5 and so on, so the code wouldn't have to change much. But if you're using the C3 module, you might notice that it only has 4 analog inputs, A0 to A3, and therefore, depending on the code that you're doing, there won't be an A4 or an A7 or something like that. So you would have to make sure that you got your analog modules connected to those 4 pins over here. They won't be good to plug into the other things there. So, and the actual software, as soon as you select this board and you try to connect it to D7 or something, or A7 or something like that, it will say, hey, I don't know what pin that is. So keep that in mind. We will be swapping different modules, so you'll probably see this happening, so that you can be in tune with that. And so now let's take this module here, and I'm going to zoom in on it a little bit maybe, or adjust the lens, make it a bit sharper. I'm going to get rid of this. Okay, so we are, I've zoomed in a little bit, and so we will leave it at that. these leads on these modules are quite long, so it's kind of, unless I hold them, it's kind of hard to get them all in the same picture and still see what's going on, but we will manage. Okay, so let's have a look at what code I have prepared. All right, so first of all, we will be using both Platform IO with the running inside of the Microsoft code editor, and we also have the Arduino IDE, and for now the code that we're using is entirely exactly the same. There is absolutely no difference because right now we're not using any libraries or nothing. And the Arduino IDE, of course, you will select the actual board. Now it's not plugged in, so I'm going to plug it in. And as soon as I plug it in, it's recognized because previously I selected that particular board. It's ESP32 Chow C3 and it is on COM5. And in Platform IO, that's a little bit different. You do have an actual board selector here, which is what you do if you create a new project. You would select the actual board from here. I put in Chow and say search, you'll see there it is, Seed Studio Chow ESP32C3. However, during these episodes that we're going to be doing on this in this series, we are going to be swapping different boards, and the actual, as soon as you select a board, it actually ends up in this ini file over here, platform.io ini. And as you can see, I have already inserted there. This is the Chow RP2040. This is the one I showed you earlier, the Chinese ESP30 Vroom 32U. And this is currently what we have enabled here, so it's not commented out. It's the ESP-C3. And if we use the S3, we'll go to that one. And this is the original Seed Chow module with the Atmel SAM chip on it. And the framework, of course, is going to be Arduino. Now, in Platform IO, you can actually define a whole bunch of stuff. If the board is not actually supported by Platform IO, you can actually set all the bits and pieces like you see over here as an example. M5 stamp C3, for some reason they don't have it. So you can actually say, okay, it's 32C3 platform, goes to the GitHub of Expressive and all that kind of stuff, and that is kind of how you do it. We're not going to go into that because that's advanced stuff. Normally you would select the board at the from the in the home page from that board manager here, and you won't have to do anything. Anyway, we have some code over here. We're going to be looking at it in Platform IO because it's a little bit more colorful and easier to read. So the only difference that you will see between the Arduino version and this version is there's only one line at the top that says include arduino.h. In the Arduino version, that is automatic because it's always in Arduino mode. Platform IO allows you to select different frameworks when you are working with controllers. There is a IDF version which comes from Expressive, and of course you can even program here in Python, like MicroPython or CircuitPython or whatever people use. But in this series here, we're just going to stick to the Arduino code. So what we have done, the first thing that we've done is we got a bunch of defines here, and we say that the LED is going to be on D7. Remember that was on the pin 7 there on that I showed you earlier. The light sensor is on A0. The light sensor is an analog board, so therefore we give it A0 instead of D0. And the motion sensor is on D5. And we got one little value here, 100, that we call after dark. And we'll get to that in a minute. We have one constant here, which is the timeout milliseconds. This for the time of the light to stay on. So if you wanted to, when the light is triggered, I got it set for 1 second right now, but if you wanted to have it on for 5 minutes, it would be 5 times 60 times 1,000. So you can work that out. And the light off time is used in the code there, as you'll see in a minute. When it's set to 0, it means the light isn't actually on. So we have a couple of little functions here. To set the light on, we do a digital write to the LED pin, and we set it to high. If it is off, we do the same thing, set it to low. But also, we set the light off time. As I said, if it's 0, it's not on. But we set the light off time to 1,000, in this case 1,000 milliseconds, or whatever you got that set to in the future. So in our case here, for this test, it is going to be 1 second in the future. If you make it 10,000, it will be 10 seconds in the future, or whatever you have set it to for the light to stay on for. So we are registering here when the light should be turned off, which is important. And when you turn the light off, well, you just set the light off time to 0, because we're not going to be counting down anymore. Some simple setup code here. The pin mode for the LED is going to be output, and we set it to low to start with, so that the LED is off. The light sensor is going to be an input, and the motion sensor is going to be an input. So we do an analog read on the light sensor, and it'll come back with the value. I think the value is set from 0 if it is completely dark to, I think it's 1,024, the maximum is that I've seen. I think that's what it is. In any case, I have determined that a good value to trigger that the light is, that it's dark, is 100, and that's what that value there after dark is all about. So if the light sensor comes back with a value that is less than 100, then we say, okay, it's dark. And then we will want to go further into the code if it is dark. If it's not dark, we don't even want to respond to anything, and we just want to make sure that for some reason, if suddenly it became light and the light off time is set to not 0, which means the light is currently on, well, then we'll turn it off. And that's all we will do. So if it is, therefore, if it is, and there's a delay of 100 milliseconds, so you could have no delay there at all, or a longer delay, it doesn't really matter. But the thing is that, let me get rid of this empty line here. The thing is that if the light sensor says that it's light, then it bypasses all this stuff, and this will be bypassed. It'll do absolutely nothing. It'll just delay and then check again. But it is dark. If this is triggered here, then we will want to query the motion sensor. And if the motion sensor comes back with a digital read that is high, then there has been movement. And that value actually seems to stay high for about 5 seconds when it determines that there is movement. So I guess that is important, because if there was movement and you're not exactly reading it exactly at the same time, at the right time, you'd never know it, would you? So it actually on purposely outputs sort of a high signal for about 5 seconds after it determines that there was some motion. And because we got a delay of a tenth of a second, that is plenty long enough for us to detect there was motion. We could actually set this, if we in some real code, we could probably delay it by a second, and as I said, leave the light on for 5 minutes or something like that. But for this test here, we wanted to be quick, so we speed it up a little bit. Any case, if there was motion, then we turn the light on. Now, if the light was already on, then we are simply just increasing the timeout milliseconds. So given that this comes back with about 5 seconds worth, up to 5 seconds worth of that it is on, then we could end up, we only got 1 second here in that where here the timeout they've got 1 second, but in fact it could actually end up staying on for 6 seconds. But that's okay. We know about that. And as I said, that is in real world code, I would really want to see that light on for at least 5 minutes before it turns off. So 5 seconds longer than 1 minute is 5 minutes is not going to make much difference, but keep that in mind. So if there was no motion, then we can check if the light is on. Then we can say, okay, well, if the current millis is in fact the time that the processor, the controller, has been running in milliseconds, so that is going to be our reference. So if the current time that it's been running is larger than the light off time, and remember the light off time was set into the future, so if it is larger than the future time, really say if it's larger than or equal to, but it doesn't really matter, then we want to turn the light off because we've come up to the time that the light should be off. So that is reasonably simple, but it is still a little bit tricky because you got to remember that this motion sensor is on, for up to 5 seconds and so on, and that will interfere with the time that the LED is on. It's never going to be on for only 1 second. It's going to be a little bit longer because of that. In any case, that is the code to do the job, to make up like a porch light or a guide light, that becomes active when it is dark, and if there's any motion, it'll turn the light on. Okay, so in the Arduino IDE, we can just hit the upload. Yep, it's done uploading. Here is our, this little sensor is very sensitive. Now I'm going to put it away from me and point it away from me over there. And I'll have to sit really still or it is going to trigger. Okay, so let me try to get that all on the screen here. So this is the LED and that is the light sensor. So if I put my finger on the light sensor, because I am actually moving, the actual light comes on, but it went off again. Now I'm waving my hand over the sensor there. It comes on and then it goes off again. Even talking, you said it's kind of sensitive. Now if I make it come on and it immediately goes off if it senses light again, if I take my finger off this sensor. So the code's working. Okay, so we've got it working just with our little LED. I have removed that LED module, and now we're going to be making it work with something that draws more power, that emulates a little bit more to what you would actually be using. This is an old Harbor Freight light that they used to give away for free some years ago, and it normally runs off 3 AA cells, and that would be 4.5 volts, but it runs fine on 5 volts as well. So I have simply soldered on some wires to actually power it off that little lead with the DuPont clips that can plug into a breadboard. And the circuit that we want to use is this here. Move that out of the way. A MOSFET, a 2N7000, which is actually this little guy here. Can handle up to 200 milliamps, believe it or not. MOSFETs are good at that because when they are turned on completely, they have very little resistance, so they don't get very hot. And a 100K resistor we're going to be putting in. So here is a little, and you know, the actual transistor over here, when you hold it like that, this is the gate, drain and source. Okay, and we're going to feed it with 5 volts. We can potentially run the board off the 5 volts as well. If you would actually making this as a circuit, you know, for a real light, then you would run the whole thing off 5 volts. Now this little board here, as I showed previously in the first episode, I put a little cell phone battery there, LiPo battery, and it actually connects to that socket over here, and this switch controls it. It can actually be turned on like that, and it'll be running by itself without having to be plugged into the USB port. But when it is plugged into the USB port and you turn it on, it'll be charging the battery too. So that's the feature of those Chow boards as well. It's kind of nice. Alright, so we got it hooked up, and of course it's overloading the camera light, but I have my finger on the sensor here, but this movement sensor over here, if I keep moving, it'll stay on, but if I sit really still, yeah, it turns off again. And of course, if I let the light in on the light sensor, it won't be turning on at all. So okay, so that shows you how you can actually run something that needs more power just using an external MOSFET with a little circuit like that. It's only 2 components, a resistor and a little MOSFET. Okay, so another option is to use a relay. You would want to do that if you needed a lot more power or higher voltage. You need to connect something up 120 to 140 volts. I made up this little relay board as I did a video on that. We designed it and created the board and everything, but you can buy similar modules to this like on AliExpress, and you probably wouldn't even need such a big relay. This one is 30 amps at 240 volts. So that's for heavy duty stuff, but this is not an option. And because these guys are controlled by a opto isolator here, they don't need to they don't draw a lot of current on the sense input. This is coming from D7 over here, so doesn't need the MOSFET to drive it. And in fact, this thing is fed with 5 volts itself, so that is what it does. Okay, so if there you go, you see I'm triggering it on the motion sensor, and I have my finger on the light sensor here. For I let go of the light sensor, of course, then it doesn't trigger. If I trigger it and I take my hand off the light sensor, it immediately turns off. So that is another option to drive something from your microcontroller. Now, we'll be doing some more interesting things later on. There's a lot more sensors. We got sort of an RFID remote control. We have humidity and temperature sensors. We have a little servo device here, and we have a little tensiometer, and we have the LED strip over here. So we're going to be using those things, doing some other episodes in this series. So don't forget to like and subscribe so that you will be notified when they are available. And until then, I'll see you guys later.